I want to go over HLOD today, specifically HLOD relating to world partition and some of the changes that have been made in 5.4. So I set up this example scene. It just has a big landscape of 8 by 8 kilometers, and I set up this little tower here, and I set up this PCG forest just to showcase some of the different methods that you can use in HLOD and how they kind of how you're meant to use them with different kinds of environments or different kinds of assets in the scene. So when you want to build the HLODs, you basically just have to go here. I noticed that during recording I don't actually always show it, but just go under build and then build HLODs, and then first delete the HLODs and then run it again, go build HLODs and then build the HLODs, and then you get this build status effect, and then you have to wait for a little bit for it to finish. If you're running out of memory, it's also possible to run the HLOD building process without running the editor, so you can free up some RAM. And you can just run the world partition HLOD builder using this commandlet. So just I'll leave this in the description along with some useful references. Also, you can increase if you're still running out of memory. You can increase the page file size of your windows, which I'll also leave in the description on how to do that. So already ahead of time as well, I set up a couple HLOD layers that I'll be using in the tutorial, and it's just they just contain the settings for all the different methods that I'll show you, but I'll go over that a little bit later in the video. So in the world settings tab, there's this new addition. They upgraded the world partition setup menu here in 5.4 with a lot of different settings. So it used to be this one, world partition runtime spatial hash, and you can see the familiar world partition runtime settings, settings here, where you can just set your cell size, loading range, grid name, all that jazz. And then in the new one, it's a little bit more modular, and companies or studios can make classes that have a custom partition streaming behavior a little bit more easily. So you can see there's a lot more settings here. You have the familiar streaming settings, but they don't directly affect the streaming of the HLOD layers. This is really for just the actual actors in the scene. Then down here there's also this HLOD setups manager, and what you need to do here is you should have already one open. You really only need one. And if you want to manage your HLODs via these HLOD layer assets, you need to add them all here in this HLOD layers section, otherwise the game won't run. And you can just keep them as is, and you can manage them from here, but there's this especially loaded section here at the bottom, and this will actually take priority over any settings that you put in here. So at least for the especially loaded, the layers with especially loaded flag enabled, these settings will override what's set up in here. So a reason why you would want to set it up this way, if you want to manage your HLOD settings in this method, where you have a unified kind of loading range cell size for your HLOD layers that you have in here, and you want different kind of layers of them. So this might be like for the very far distance, you could have one with a loading range that's really big, and then you could add another one where the loading range is much smaller, for instance, or the other way around, but you whatever you prefer, right? And then with a denser cell size. But really, in practice, I think most users will be able to manage with just like one layer and have your little different methods of breaking down or setting up these HLODs per whatever asset you need. So there's in the city sample project, it's actually set up with different HLOD setups, so you can take a look at that if you really want to dive into this. But I think in general you can leave this ticked off and just manage like this. Right, so here we have the tower, right? Just built out a couple simple cubes. So let's take this tower for example. So say this is a really high poly mesh, right? I just built it like a little block out of a couple cubes. And this is like you have a lot of gameplay systems going on here and a lot of actors, and you're noticing that if you're really far away, It's kind of a drag on performance, and it's not really doing anything because you can't interact with it or you can't see it properly. So you want to simplify this with the HLOD system, and you have all this detail in here, right? So first step would be just to decide what needs to be included, right, for the HLOD consideration. So if you take something like this, for example, yeah, it's not really required. So you just go in the search bar here, you type HLOD, you find include component in HLOD, include actor in HLOD, and you just disable it all. So you disable it for all this stuff, and maybe you can go into the interior as well. You know, and you don't need these floors and you don't need these little actors, so you disable them all here. Yeah? You can do it all at the same time by if you just click them all, and then you can adjust it. And then for these ones, these big volumes that you see on the outside, you want them included, of course. So you include them and you select the appropriate HLOD layer. And I want to check with you guys on some of the different methods and what it exactly does. So right now it's set to approximated mesh. And it already alludes a little bit to what it does in some of the settings here. If you see clamp voxel dimension, so if you know what a voxel is, right, you already know what it's gonna do. So I'm just gonna run this, and then I'll show you really quickly what it looks like or what happens. Right, so here is the generated structure. You can see now with the new 5.4 update, the grid is three-dimensional, so now they also separate in terms of like the z-axis, the HLOD. So you can see here that it's created a mesh that's basically seamless. So if you remember before, it was all separate cubes, all separate objects, and right now it's optimized into one solid mesh. And you can see as well some of the problems that this method can have. I mean, it's far away, so you don't really see it, but you can see the bevel, for instance, on the edges. This is due to the voxelization of the mesh, of course. So if you imagine in Blender here, this is kind of a similar setup, right, of the object, and you just, what it does is it just selects all these objects, it merges them, and then if you go into scope mode here, we can remesh the object, and you can see it does more or less the same thing. So you can see you get these bevels here, which you may or may not want, and may or may not be suitable to optimize your object. Of course, in Unreal, there's some more optimization than that. As you can see, it probably reduces, there's a reduction pass as well on it, and it tries to maintain the edges. So that's to do with this setting here. Simplify method, right? So you can see your geometric tolerance, or you can do a fixed triangle count or triangles per area, right? So you can get different methods of simplification here. Yeah, because it's voxelization, sometimes, you know, voxelization, it requires a solid mesh, so sometimes it might fail for your case. So you can try maybe with this capping option, see if it fixes it. So there's a lot of options here that you can experiment with to get a better result if you're having issues. Right, let's take a look at the merged mesh. So here's the merged mesh, right? So you can see it's generated the same chunking as before. And then if you go into the wireframe mode, you can see it's a little bit less optimized. But basically what it's done is it's grabbed the highest LOD, so like the lowest geometry LOD that you have, and then it's just merged them. So instead of like having a lot of separate instances and draw calls, you generate just a merge mesh. Yeah, it's pretty straightforward. Basically what it does is this. Take the mesh, merge it. That's it. Again, there's a couple options here that you can play with if you're getting not quite the result that you want. Mostly to do with the material and light map baking, that kind of stuff. If you're doing an open world, you're probably not doing too much light map baking though, so probably not that interesting. You can toggle that off as well. All right, and then let's take a look at another one you might want to use for buildings, which is a simplified mesh. So here we have the simplified mesh. Let's take a look at the wireframe. So you can see it's quite similar in terms of the wireframe. It's quite similar to the the approximate mesh, the voxel mesh. But it basically does, what it does is this. It just takes the object and then duplicates it, merges it, and then it's merged by distance. most likely, and then just increase that, and you can see the topology simplifying, and then they simplify just in terms of like flat surfaces probably, and they just take this and they dissolve these edges. Okay, well, can't do it here. You get my gist, and they they take the interior faces as well, and they delete those, and then they can optimize the topology like that, and you get a little bit of a simplified mesh. So here, proxy settings. There's a bunch of settings again that you can play with if you don't get the desired result, right? So material settings, you can check the texture size, all that jazz. You can adjust the roughness and stuff if it's not quite to your liking. Here, there's a create collision flag for this one. Probably want to disable that one because you're never going to be interacting with this this mesh as a player. So let's take a look at an example for the instancing system then, the HLOD instancing. So I've got this little PCG setup here that generates these trees in this forest. And the way I set it up is that it's modular, right? So the trunk is separate, the roots are separate, the branches are separate. So it's all separate instances, right? So the way I set it up is that these branches and the leaves, they get cold if you get a certain distance away from it. And then I gave the, here I'll show you in the asset actually, I gave the trunk a billboard that exists with all the branches and stuff. Yeah, let me just select the HLOD 1 so you can see it just exists as a really simple billboard. It's just for presentation purposes. So I want to bake this out into then an instance, right? In an instance HLOD. So if you go far enough away, all the branches get cold and you get this little billboard instead. Now, if this was already a foliage actor, so say you went into the foliage mode and you painted this foliage, or you have some other PCG setup and it's just the tree asset itself, and you then want to bake it down into an HLOD, which also uses instancing, you're not going to see that much of an improvement because it's already using the same system, basically. It's already instanced. So what you might see is that because in the HLOD instancing setup, they use an instance static mesh component instead of a hierarchical instance static mesh component. So you might see a little bit of a gain in terms of memory usage because it doesn't have to load in all the LODs, it just has to load in the highest one. So that's the lowest geometry one, the one that loads in when you're furthest away. But even then, probably if it's an asset like this, which is a tree, which is everywhere, you're probably gonna have that in memory anyway. But since I have it set up like this, where you have these branches and these leaves, and just a trunk that I want to be that I want to bake down into the HLOD, you actually do get some performance gain out of it. So I'll show you if you have a PCG setup like me. Let me check here. So if you go into your static mesh spawners, you can set up basically. So here you have this, I think if you just type it here, HLOD. Including the HLOD. So I don't want the roots in there, so you have to go in every static mesh spawner and you have to set the setting, and then here is for the trunk. So I actually do want it included in the HLOD, so I click yes, and then in the here in the PCG forest actor in the scene, there is also some HLOD settings, and this is then where you assign the correct HLOD layer, which is the instancing one for me. And then if we bake this out, I'll show you what it looks like. Just delete them first always and then build new ones. So here's the resulting HLOD. You can see inside it's just a hierarchical instastatic mesh component, and which is locked to the lowest geometry LOD, or the highest LOD. So for the landscape, by default, if you check also the example map that they have, what they do is they set it up as an instancing as well, and then they disable spatial loading, so it's always loaded in, which I think for a lot of HLOD scenarios it's really preferable, unless you really have a really big level and you have to manage these HLOD layers as a streaming distance with streaming distance from world partition itself. But I think in most cases you can just disable this flag and it will always be loaded in. Doesn't mean that when you get close it's still loaded in. I'll show you that in a bit, but basically you'll always see it, and then when you get close it will load in whenever the appropriate asset needs to be loaded in by world partition. The HLOD will disappear and then you can see the regular asset. So I'm gonna bake this out and then I'll show you what it looks like. Or actually first I want to go over, basically they updated in 5.4 I think this HLOD, the way the HLOD works for the landscape. So let me load in the entire landscape and then show you some of the new settings. So under the kind of the parent landscape we have now this HLOD section. So this didn't used to be here, but what it does kind of in the background is it loads in, if you remember from the LOD video that I did for the landscape, it's just gonna check for like the lowest LOD that it can make for the landscape, which right now it looks really dense, but you'll see that actually it'll be quite nice. And then so you have this new section here for baking, for some settings on the landscape for baking the HLOD. It used to be kind of buggy. And they improved it since, so it's been much more stable in my experience for making this tutorial. And basically you have this section here where you can specify if you want to automatically determine the resolution for the texture set it's going to bake. So it's going to bake down the albedo and the normal map, and it defaults to 256 here. You can specify here as well the way it should generate the LOD that you're going to see in the HLOD, and it specifies or it defaults to this lowest detailed LOD that I think it can generate. And I'll show you what it looks like when I generate this. Here are the generated HLODs. You can see in here, yeah, it's super low resolution. And it generates them with albedo map and normal map. You can see actually that the roughness is quite high. So you can go in here and you can see in the landscape, whatever, mesh proxy component here in the static mesh, you can see the kind of the mesh that it created, and you can see the material instance as well that it has. And you can see that there's this roughness constant that you can tweak actually. It's kind of annoying because you have to tweak them for every component, but you could also jump over to the parent material and edit this if you prefer. So I don't know where the roughness is. Oh, it's here. So you have the roughness constant here. You can set to a default value or a different value as well if you prefer, but probably just tweak them here is best. So if you want a high resolution LOD for your HLOD for your landscape, just go in here and click on this HLOD mesh source LOD policy, and then instead of lowest detail LOD, choose specific LOD, and then start with a number like 5. And then you can go down if it's not high resolution enough. So a higher or a lower number means like a high resolution asset, right? So let me bake this out and I'll show you what it looks like. So here's the asset, and it's a little bit more high resolution than what we had. And you can see, yeah, that's it basically. And if you need a higher or a lower resolution, you can go with a higher or a lower number. Yeah, and that's it. And I have to add as well for the landscape, to be honest, I think in most cases people can get away with just not having an HLOD for the landscape at all. Just optimizing the landscape like I showed in the last tutorial and doing it like that. And if you need something for in the background, really just don't add a landscape actor or anything like that. Just add a simplified mesh that's representative of the landscape with some baked in lighting or anything like that, and that will serve your purposes probably fine, and it'll be much simpler. One more thing that I forgot to show actually is you have this parent layer option here in the HLOD layer settings, and basically what this allows you to do is to set up like an LOD chain like you would expect from a normal asset, right? So you have your LOD 0, 1, 2, 3, and you can do that with HLOD as well, where you add a chain where you have high resolution HLODs as you get close, and set the parent layer then so the HLOD layer knows which one is above it, right? So your highest parent would be your lowest resolution LOD, and then the kind of the leaf node the leaf child of this chain will be then your highest level or highest resolution HLOD, if that makes sense. So I'd like to leave you with this thought as well, that HLOD, we looked into HLODs today for Unreal Engine and for world partition, and specifically the tools that Unreal ships with to make HLODs, right? But the HLOD is not really something that Epic came up with. HLOD is just a method to decrease the amount of instances and the complexity of the scene as the scene recedes away from the player, right? So if something is further away, you simplify the scene and you break down these objects into different objects, and you're not limited to the tools that Unreal ships with. You can use different methods as well. This is a very good talk about some of the tools that Simpligone has made and some of the methods as well that they employ to make HLODs. And you can do this stuff even in Blender as well. You can make your own pipeline to bake out simplified meshes. And for the example, for instance, for the forest that I shown you, where we bake down these branches into or these trunks into these imposter instances. Even better solution would be to kind of render the foliage as a whole, the forest as a whole, and make one big imposter for the entire forest, or maybe several smaller ones that kind of compose this forest then in the distance. So instead of all these instances, you have these bigger clumps of forest. And even then you could even bake them down further and merge them with the landscape, like a landscape proxy, and the buildings that are near there. So it's really just be creative with it, and don't be limited to whatever the HLOD tools that Unreal has. And sometimes they can be a little bit frustrating to work with as well. They can be a little bit buggy, but you're not limited to that. You can use whatever workflow you like to achieve this optimizing effect, right? With this HLOD, the idea of a HLOD. All right, that's it for this one. I hope it was useful.